How's it going, everyone? Welcome, Eulier Gonzalez here. And today, let's take a look at this particular topic that to me was quite hard to understand. So let's get into this. And first thing first is to know what are we gonna do in today's video and how do we get here. So this is talking and looking up the observable behavior of closures. So here you have now this observable definition, right? So based on what we can observe when you define now a variables inside of a function that is referencing from some from the outer scope, and then you return is the function instance, so you can let it on in a different scope execute that. It turns out that that variable reference is whole somehow, right? The inner mechanism will actually go beyond the scope of today's video, but it's important that this is the observable behaviors, okay? And as we look at how can we create these closures that is not exclusively for a functions wrapping another function. This is a feature from functions and only functions, that when you want to have access to variables that live outside in the outer scope, whether it is block scope or function scope or even the global scope, and then return that function at some point in time, or return that instance of the function, and then execute that in a different scope, then JavaScript now remember that variable reference. So traditionally, we look at this as this function, right? And here we say, hey, this will be our counter, okay? And here our counter will have, we can call this now counter function. And here we can define it as a variable or a let, all right? In our case, we prefer to use now var to indicate that this identifier, it'll be scope per variables, per functions, or global scope, right? So we have now our variables here, named counter. We can initialize that as zeros, and then define a function here that'll be called increment, all right? And this increment will hold a reference to these outer variables that live in the outer scope. So for example, counter, and then I do want is to first, I do want is to increment this counter and assign this value and give it to me, right? After that, I can return now is the increment here. So why do we have this particular syntax here? Why do we define its functions here and variables here in this way? So the logic is, according to Kyle Simpson, is that functions, in order to improve the readability of the code, first define is the executable function code first, and then the declarations. And this is the reason of why hosting exists, okay? And for variables, use them when you see fit, whenever you need them, right? This is why you see in a lot of particularly example of Kyle Simpson that he does this kind of setup. So they put all of these functions at the bottom, right? And all of the executable code first. So in our case, right? So after we now first invoke that function, and then For example, here, right? You say, hey, let's say his seconds, or let's say now hits, right? And this hits, let me actually make this as a let, and this hits, why you change that to let uncount in this case doesn't matter. It's just if I want to reassign that value, I can do that later on. And then I call that counter function, and because this return now a function's reference, aka the value, so if I now try to print this hint, I get is the function value, and what this function value is. All right, and what I try to now is call hits, then of course it's not returning anything, so let me return here, my bad. Return the counter, okay, and when I call now hits one time, it will give me 0. And if at some point in later in the code, or even in a different scope, right? So for example, if this is true, this is just for simple example, right? Or if the array dot of, we can say, hey, Ronco is running, right? Some variables here that you might define. You may say, hey, true. So if it's running, right, then I want to now is call that. Again, here we're not creating is a new scope. This is one of the things that most people might my found you might find a confusion here with a lot of this, but only when you create now is a var letting cons or even a function. This is when now this becomes a block. And there are also some reasons of why we should avoid function in block scope. And if you find yourself in the need to do that, why it is preferred to use now a function expressions to hold now a reference of that function and then later on go into that. So, but in any case, here, if we try to execute that in a different scope, so let's say, hey, we're getting here, and say this is greeting, and greeting is now hello. This blocks becomes now is in a scope thanks to this identifier. We can now console log is the greeting, right? And then in a different scope we can also call now hits here, right? And as you can see, the observable behavior is this, right? That it must be a function, okay? So the key part of this definition, that is, a closure is observed when a function, exactly, a closure is observed when a function's variable from the outer scope, whether it's a block or a function scope or even a catch, right? And for the try catch, even while running in a scope whose those variables wouldn't be accessible, this is observable when you now is invoke the functions in a different scope. Inside of those functions, it has now a variables pointing to the outer scope, okay? And that function can be invoked in a different branch of the scope from the variable. which is here. We are executing in a different branch of code from the environment. Okay? And now somehow JavaScript, again, I know that this dev tool is not a 100% JavaScript compliant, but the observable behavior here is that actually match our intuition. So why this is important, you may wonder. Well, it's something that we're going to see that in today's video. And also is that it is also important to not only create a closure, but know how to get rid of that. Okay, how to now release that from memory. Because at the end of the day, that reference is a live link. You can update it, but you can have access directly to it, right? Only via a function. So we're looking is now at this, the closure lifecycle and garbage collectors. So since closure is inherently tied to a function instance, it is closed over a variable it is closure over a variable last as long as there is still reference to that function. Exactly. So a closure lasts. So a closure over a variable lasts long as there is still the reference to that function. So in this case, if I now try to have access to hits, I still have access to, but the closure over a variable remains as still they have a reference to that. So if for some reason now I say hits is now empty, all right, now we make that function reference a candidate to be garbage collected. So if 10 functions all close over the same variables, so that's some hypothetical example here, right? It's all of those functions. So for example, function here, decrement, right? And then you say now return is less counter, all right? Right, and here you want is to now return is a reference to this increment, oh my god, and decrement, right? Hit is not a function. Yeah, you're right. Hit now is an object. That it has now the increment function, all right? So here, if you have several functions referencing that, which is in this case here, right? If you have now several functions referencing that variable, if 10 function has all close over the same variables, and over time 9 of them functions are discards, the lone remaining function reference still preserves the variables, and once the final function reference is discard, so you reassign it with a different value or you just point that to null, so the last closure over the variable is gone, and variable itself, it is garbage collected. So this has an important impact on building efficient and performant programs. So closures can unexpectedly prevent the garbage collector of a variable that you otherwise done with, which leads to runaway memory usage over time. That's why it is important to discard functions reference and those their closures when they are not needed anymore, right? So In our case, it is also important to discard those functions here. Let's take a look at this example, shall we? Let's take a look at this particular example. So consider this function manage button click events, right? Click handlers, return function listener like this. If CB is this, let's click handler here. Function on click, console.log click, callback event here is here. So here we are now creating a variable here with click handler, a collection of them. So we're gonna return this function, okay, called listener that is gonna receive is a callback, and it say, hey, if I receive in this callback, which is a function, so now let me is create a function that is going to now invoke that function and pass that as a referent. So let me create now a function here. Okay, so let me create now a function here that I'm gonna use that to execute that callback only when this button has been attached to, or only when a user event happens. So what's doing here is now handling is asynchronous operation, because this is something that is not going to happen right away. In fact, it will wait for the user to do click. Okay, so far so good, right? So because now when you create these functions on click here, you are holding a reference to an outer identifier, in this case CB. You are closing over CB here, okay, and now attach that. So you are closing over CB and attach that functionality reference when you need that. That's exactly what you're doing here. When you need it is on click. So if no callback is passed, so let me now is get rid of all of those callbacks that I have attached to this. Let me actually is get rid of all of the close over variables that I have inside of this function's reference to do so, right? So here what it's saying is, hey, let's going to go over all of these click handlers that we collect to. So all of these click handlers that we collect to, right? And then I want to now is delist it or remove them, remove those reference from the bottom here. There is a couple of things here that I am not quite familiar. For example, the add event listener and remove event listener. But based on the JavaScript here, it say, hey, when you listen is click, all right, you will have now this handler attached to, which is part of the event driven. So if we take a look at the MDN for a moment, okay, and then you have now this add event listeners, okay. So it comes from the event target interface that set up a function that will be called whenever the specified event is delivered to the target. Common targets are elements, exactly, that will call whenever the specified event is delivered to the target. Common targets are elements of it or its children, document, and window, but their target may be any object that support events, such as IDB requests. So any object that support events. Okay. So what I did? Okay. that support events. The event listener method is recommended way to register an event listener. The benefits are as follow. It allows adding more than one handler for an event. It's particularly useful for libraries in JavaScript models or any other kind of code that needs to work well with other libraries or extension. In contrast of using an on X, Y, and Z property, it gives you finer grained control of the phase when the listener is active, capturing versus bubbling. You know, there's some concept here, the phase when the listener is active. It works on any event target and not just HTML and SVG elements. On any event target. Okay. So if that element support events such as IDB requests, okay. The method add event listener works by adding a function or an object that implements the handler event function to the list of the event listener for the specified type on the event target, on which is called. If the function or object is already in the list of the event listener for this target, the function or object is not added a second time. Note, if a particularly anonymous function is in the list of the event listener register for a certain target, and then later in the code an identical anonymous function is given in an add event listener call, the second function will also be added to the list of event listener for the target. Indeed, anonymous functions are not identical, even if defined using the same or changing source code repeatedly, even if in a loop. Repeatedly defining the same unnamed function in such case can be problematic. See memory issues here. So for example, if you now define, for example here, memory issues. In this case above, you get element by tag name. Okay, you're gonna get a collection of elements, which you're going to add the event listener to that, click, and this anonymous function, right? The case 2 is function process event and do something. So then you define now the process event, all right? And then you add now an event listener here. Because here you are, okay. In the first case above, a new anonymous function handler function is created with each iteration of the loop. In the second case, the same previously declared function is used as an event handler, which result in a smaller memory consumption because there is only one handler function created. Okay. So you are passing now is a reference here, rather than in this case creating as an arrow function each time here. Exactly, makes sense. Moreover, in the first case, it's not possible to call remove event listener because there is no reference to the anonymous function is kept over here, not kept to any of the multiple anonymous functions the loop might create. In the second case, it is possible to do my element dot remove clip event listener. Here, process event false because process event is the function reference. Actually, regarding memory consumption, the lag of keeping a function reference is not the real issue. Rather, it is the lag of keeping a static function reference. A lexical reference here, because you can create is all of this function memory every time that you are creating an event listener, whereas here you are only passing is one reference to that. And if you want to unregister that or remove the event listener, you can do that, aka you can freeze up memory for that. If an event has a default action, for example a wheel event that scrolls the container by default, the browser is generally unable to start a default action until the event listener has finished, because it doesn't know in advance whether the event listener might cancel the default action by calling event.prevent default. If the event listener takes too long to execute, this can cause a noticeable delay, also known as jank, before the default action can be executed. By setting the passive option to true, and an event listener declares that it will not cancel the default action, so the browser can start the default actions immediately without waiting for the listener to finish. If the listener does then the call event.prevent default, this will have no effect. The specification for that event listener defines the default value for the passive option as always being false. However, to realize the scroll performance benefit of passive listener in legacy code, Fire browser has changed the default value of passive options to true. For the wheel, most wheel, touch start, and touch move. This prevents the event listener from canceling the event, so it can block page rendering while the user is scrolling. Because of that, when you want to override the behavior to ensure the passive option is false, you must explicitly set that to improving scroll performance using passive event listener. I do think this is so it won't block the UI if you put that as passive. Initially the listener is passive, so trying to scroll the container with the wheel is immediate. If you uncheck passive and try to scroll the container using the wheel, then there is a noticeable delay before the container scroll, because the browser has to wait for the long-running listener to finish. That's what they've set now to passive, as it is. And now they heavily use query selectors with the index here instead of document get element by ID, or query selector with this. Okay, all right. Okay. The type representing the event type of this, which is a hash table for that. This is the event index, whether it's animation, asynchronous data fetching, clipboard. Clipboard, composition, events files on element, CSS transition, database, DOM mutations. Mutating events are deprecated. Mutation observer should be used. Drag and drop wheel, event related to using HTML drag and drop and wheel events. Focus, event fires on elements in window. On elements in window. Okay, drag start, drag stop, drag enter, drag leave, drag over, drop, drag in. So you put now this as draggable as a property, so you can drag this element here. If you put this as false, you can drag this element here. So for image and link, draggable defaults to true. Okay, now things starting to make a lot of sense here. So forms, event related to forms being constructed, reset and submit is also give you now that reset and submit as well as the form data. Okay. Full screen API. Okay, gamepad APIs, gestures. Touch events are recommended for implementing gestures. Event fires on documents and elements. History. Event fire on window. And you have now different events here. So for example, pop state. Inputs, exactly like input, selection text area, keyword, loading and unloading document, manifest, media, messaging, mouse events fired on elements, payment requests, event fired on payment requests and payment response. Part of this API, limited availability. Firefox doesn't support that. Shipping option and shipping type. Merchant validation, payment method change, shipping address. All of these are being deprecated. But payment method change. Okay. That's interesting. Firefox hasn't implemented any of that. The reason? That is quite interesting that he hasn't implemented that, the payment request API. So Safari has implemented, but not Firefox. That is quite interesting. But in any case, except event fires on payment request and payment response, performance, pointer, print, promise rejection, socket, SVG, touch, virtual reality, RTC, WebRTC, servers and events, event source, speech, events related to web speech API, workers. But this is all the list of, or the event index, right? The event index, whether it's animation, which is something that I know quite familiar with, the web API animation, which is something that we're going to look at later on, not in today's video, but in other videos. But it's that repeatedly defining the same unnamed function in such case can be problematic here. Mm-hmm. Okay. A case-sensitive string representing the event type to listen for. Mm-hmm. So, um, in an event target interface is implemented by object that can receive events and may listen for them. Elements and its children, as well as document and window, are the most common event targets. But other objects can be event targets too. For example, IDB requests, audio node, and audio context are also event targets. Many event requests, including elements, document, and window, also support register event handler via on event. Mm-hmm. Mm-hmm. And similar for passive. A Boolean value that, if true, indicates that the function specified by listener will never call prevent default. If a passive listener calls prevent default, nothing will happen and console warning may be generated. If this option is not specified and is set to false, if set in that browser or the Safari, it defaults to true, wheel mouse to each other moves events. And signal. Also signal here. The listener will be removed when abort method and abort controller here. But again, this is go beyond too much in the detail, get lost in the translation of the detail. But it turns out is that. So the point of closure is not only to observe not only to describe the observable behaviors, but to also is, since you're holding a reference of a variable from an outer scope inside of these functions, and create an instance functions that can be now is executing a different scope from the variable, okay? In JavaScript, remember these functions reference. If you have 10 functions referencing or closing over that variable, and 9 of them are gone, the lone function reference will still make that variable live, right? So only when that function reference is gone, only when that function's reference that is closing over that variable is gone, then is when you can now make that variable candidate for garbage collected. So why this is important? Because this can lead to several of these memory leaks that we can find in our applications, especially when you're using is closures here. And how important is to put a guardrail to prevent that. All right. Okay. All right. Okay. So in this program, the inner onClick function holds a close over the pass CB, the provide event callback. That means the checkout and track actions function expressions. In this case, that the checkout and track actions function expressions. That means that the checkout and track actions functions reference are held via closure. Exactly. Are held via closure. Well, they mention function reference because this is the value that is being passed to or assigned to. for as long as these event handlers are subscribed. When we call submit with no input on the last line, all event handlers are subscribed and the click handlers array is empty. Once all click handler functions reference are discarded, the closure of the CB reference to checkout and track actions are discarded. When considered the overall health and efficiency of the program, unsubscribing an event handler when it is no longer needed can be even more important than the initial subscription. Per variable or per scope. Another question we need to tackle: should we think of closure as apply only to the reference outer variable? Or does closure preserve the entire scope change with all of its variables? In other words, in the previous event subscription snippet, is the on-click function close over only CB? Or is also close over to the click handler exactly, is this only close over to CB? All right. Or is also closing over of the or is also closing over click handler and click handlers and bottoms. Or click handlers and bottom. So for example here, exactly, is this holding a reference of the callback CB, or is also closing over click handler and bottom? That's a very good question. So what is the observable behavior? Conceptually, closure is per variable rather than per scope. Ajax callbacks, event handlers, and all other forms of function closures are typically assumed to close over only what they are explicit reference. But the reality is more complicated than that. Another program to consider. So when you have is this, right? Student records. When hit student records, you're going to map over, so iterate through all of the elements and apply this function called get grades to only get the grades. And once you have that, right, where you are passing now a function's reference here, and then assign this, if a student record is huge, you're also going to now hold in memory here is this large, in this scope, this large amount of records here, okay? 10,000, 20,000, a million, okay? And then you say, hey, let me now return is the add grades. So not only that student record is still in memory, all right, because you hold them here as a reference, right? But when you now add the grades, when you say, hey, now that I have all of the grades, I do want is to, when you call that, and pass me the new grade, I want to push that to the new grade. Sort entering grade list. So this sort function, what it's doing is, if you want to now sort things in an ascending order, right? So the first element, so the difference between the first element and the second element, if the first element is greater than the second element, or exactly, if the difference if the difference between the first element and the second elements is positive, so it's gonna now do that in an ascending order. Okay. If the opposite of happens, which is the second element is, so the second element, or the difference between the second element and the first element is negative, which means that this second element is greater, well, now we're going to sort our element in a descending order. Okay, in a descending order. So a rule that I use to remember how this sort compare function works here is by this. You're gonna pass now a function that if the difference between the first element and the second element is now positive, aka is this, so a minus b is positive, so we're gonna use this first element as a reference. So if this is bigger than the second, so we're gonna sort elements in an ascending order. However, if the first element is now, so now the second case is if the difference between this is negative, aka the first element is smaller than the second one, so now we're going to sort this in an ascending order. All right. So that's the rule that I use here. So is that so is the difference here? So if the first element, okay, let me put that at test here, right? Let me put that at test here. So if you say, for example, 1, 2, 3, 4, let me put it this way, right? If you want to sort that in an ascending order, okay, I'm going to pass now a function's reference here. We'll receive is the first and the second as parameters, and then you're gonna say, hey, if the first element if the difference between the first element and the second element is negative, okay, which means that the second element must be larger than the first element. The first element, exactly, the first element is smaller than the second one, right? This will sort now in an ascending order, but I don't think this is the case. It means that this will sort that in an ascending order. Exactly. This will sort that in an ascending order, right? So this will sort in an ascending order. However, if this is the opposite, okay, it will sort that in a descending order. For example, like this, it will sort that in a descending order. This is the observable behaviors. Okay. Exactly. So if this now is negative, all right, if this now is negative, Mhm. Okay. Mhm. At grade. So the other function manage student grades, take a list of the student records and returns an at grade function reference, which we externally label at next grade. Each time we call at next grade with a new grade, we'll get back a return list of the top 10 grades sorted numerically descending. See sort and trim get sort and trim grade list. From the end of the original manage student grades call, the between the multiple at next grade calls, the grades variable is preserved inside at grade. Via closure. That's how the running list of top grades is maintained. Remember, it is a closure over the variable grade itself, not the array it holds. That's not the only closure involved. However, you can spot other variables being closed over here. For example, so that's grade. Can you spot on another function that is closing over? The sort and trim grade list. Here, because you're referencing identifiers that are out from the outer function scope, right? So did you spot add grade reference, sort and trim grade list? This means also close over that identifier which happens to hold a reference function here, right? The second inner function has to stay around so that at grade, for example, like that, can keep calling it, which also means any variable it close over stick around, though in this case nothing extra is close over here. What else is close over? Here we are closing over a record that is only going to live is inside of this map. Consider the get grade variables and it is function. It is a closeover. So it's a hey, get grade, specifically record.grade, is something that is being passed here. If you define it as a function here, you're going to receive now that record, all right, and return that record here. It is referenced in the outer scope of manage student here. So manage student grades at next grade here. So it is reference to the outer scope manage student grade in the map grade call, but it's not referenced in the add grade or sort trim list. What about the potentially large list of student records? We pass to the student record. Is that variable close over? If it is if it is, the array of a student record is never getting garbage collected, which leads to this program holding onto a large amount of memory than we might assume. But if we look closely again, none of the inner functions reference student records. So none of the inner function student reference student records. Exactly. According to per variable definition of closure, since getGrade and student records are not referenced by inner functions, they are not closed over. They should be freely available for the garbage collector right after the managed student gets grades called completes. Indeed, try debugging this code in a recent JavaScript engine like V8 in Chrome and placing a breakpoint inside of the addGrade function. You may notice that the inspector does not list the student record variable. That's the proof, debugging wise anyways, that the engine does not maintain student records via closure. But how reliable is this observation as proof? Consider this rather contributed program. When you have is this var info store student info 73 Susie and 87. So because here is using eval is a bad idea, which it's a if there is a property called name. Oh, so you are now this is a very bad idea. You are now creating as a closure at runtime. Notice that the inner function getInfo is not explicitly closed over any of the ID, name, or grade variables, and yet calls to info seem to still be able to have access to the variables, albeit though use of the eval lexical scope cheats. By creating this reference here, right? You can modify the scope at runtime. You shouldn't do that. And that's a very bad idea. To modify is with runtime. The modify is the scope at runtime. Okay. That's a very, very bad idea. That's a very, very bad idea. So all the variables were definitely preserved via closures, despite not being explicitly referenced by the inner function. So does that disprove the per variable assertion in favor of per scope? Depends. Many modern JavaScript engines do apply an optimization that remove any variable from a closure scope that aren't explicitly referencing. However, as we see with eval, there are situations where such an optimization cannot be applied, and closure scope continues to contain all its original variables. In other words, closure must be per scope, implementation wise. Okay, and then an optional optimization trimmed down the scope only what was closed over, a similar outcome as per variable closure. Even as recent as few years ago, many JavaScript engines did not apply this optimization. It is possible your website may still run in such browser, especially in older or low-end device. That means it is possible that long-lived closure, such as event handlers, may be holding on to memory much longer than we will have assumed. And the fact that it is an optional optimization in the first place rather than a requirement of the specification means that we shouldn't just casually overassume its applicability. In case where a variable holds a large value like an object or an array, and that variable is present in a closure scope, if you don't need the variable anymore and don't want that memory held, it is safer memory usage to manually discard the value rather than rely on a closure optimization garbage collector. Let's apply a fix to early managed student example to ensure a potentially large array held in a student record is not caught in the closure scope, which is after you get that, remove it. We are not removing a student record from this closure. We are from the closure scope that we cannot control. We're ensuring that even if the student record remains in the closure scope, that variable is no longer referencing the potential large array of data. They can garbage collect it. Again, in many cases, JavaScript might automatically optimize the programs to the same effect, but it's still good habit to carefully and explicitly make sure we don't keep any significant amount of device memory tied up to any longer that is necessary. Hey, I don't want to unnecessary keep this memory. I don't want to unnecessary keep this memory field when I create a closure here. And especially if you're referencing as the student records here. Especially if you're referencing is now a derived state from that variable, because at the end of the day it's all about reference identifiers. So if you are referencing an identifier, it is safe and you don't need to use that any longer, then you can do that. Then it is safe for us to remove that. Okay, unset student records to prevent unwanted memory retention in the closure. The takeaway, it is important to know where closures appear in our programs and what variables are included. Exactly where closures appear in our programs, and it is when we are referencing exactly if instead of a function we're referencing to a variable or an identifier from the outer scope, and then invoke that function in a different scope from the variable. So for example, in this case here, in a different scope from this environment, right? And inspect where closure happens with grades and how you can now remove those references. Know where closures appear in our programs and what variables are included. We should manage these closures carefully so we're only holding on to what's minimally necessary and not wasting memory. Okay, so that'll be all for this video. Take care. Bye-bye.